All right, so last section we're going to look at is it's half a section, 7.2, and it gets more into the inverse trig functions. All right, so first of all, the inverse for any function, not just a trig function, but anything, it's a mirror image. What's it a mirror image of? It's a mirror image over the line y equals x. Okay, and I'll show you that with two functions that are inverses. What's the inverse of squaring? We don't normally call it that. We call it a square root. Let me graph a square root and a square function and show you what happens. So if we have square root, all right. So here's a square root, and here is squaring. These are inverses of each other. What I'm going to do though is I'm going to graph this a little bit special. I only want to graph the positive part. Okay, you'll see why in a second. So I'm just going to graph when x is greater than or equal to 0. Okay, watch what happens when I graph these. There's your square root. Focus on quadrant 1. Okay. There's your square. If I were to draw the line y equals x, just like that, that blue line and red line should be mirror images of each other. It's a little hard to see because the line is kind of thick, but you can just kind of visualize that. The blue line and the red line, if you flip them over that line, they're mirror images. Okay, that's what I'm trying to show you. So that's true for any inverse functions. They are mirror images of each other over the line that I just drew in black. So the problem is, for a function to have an inverse, it has to pass the horizontal line test. Let me show you what happens if I graph what was in y2, but I don't put in parentheses at the end. I'm going to get rid of that. And I'm going to get rid of what's in the parentheses. Watch what it looks like now. It's not just half a parabola. I get the whole thing. And the problem with getting the whole thing is that. That graph right there that you see on the calculator fails the horizontal line test. Not the vertical line test, the horizontal. What that means is if you have a graph and you draw a horizontal line and it hits your graph more than once, your graph does not have an inverse. So there is no such thing as an inverse for that picture. That's why I had to do what I did before. I had to only graph half the picture, okay? And then it works. Well, let's think about the graph of sine. Okay, here's your graph of sine. Okay. If I were to draw a horizontal line, would it hit the graph more than once? Oh yeah, it's going to hit more than once. It's going to hit it, if you keep drawing that wave forever, it's going to hit it infinitely many times. Well, that means that the graph of sine fails the horizontal line test, and that means that it does not have an inverse, if we think about the entire picture. But we know that's not true. We know sine has an inverse. We talked about it last time. So, what we do is we say, you know what, we're going to block out part of the graph, and all we're going to do is focus on a certain section. We have to focus on a section that, if I were to draw a horizontal line, it only hits once. So what do you think in that section? If I draw a horizontal line, would it only hit the graph once? It could, but could it hit it twice? Right, I have to come up with a section that it's impossible to hit twice. And if I do something like It's a little off, but basically just like that. No matter where I draw a horizontal line now, it would only hit once. So that's the only way inverse trig functions can exist. You have to basically block out the rest of it and just focus on a small part. And that's what I'm trying to show you right here. Okay. So, the solution, what I just said, we're going to focus on a small part. So in order for sine to have an inverse, I want you to think about this window, which is really from this line to that line. We're only going to look at what's between those red lines. And those marks are negative 90 to positive 90. So if all we do is focus between negative 90 and positive 90, we're good. Then sine has an inverse. Okay, and I'm going to tell you a couple facts about inverse sine. Okay, I'm going to tell you what the domain is and what the range is. And then I'll do the same thing for inverse cosine and inverse tangent. So these might be some facts if you make a reference sheet you'd probably want to put on it. Now, when you have an inverse, I told you that everything is a mirror image over the line y equals x. Let me go back up to that for a second. Let's move this off. Y equals x. What that means is y turns into x, x turns into y. That's what that equation means right there. Y equals x. So if x is turned into y and y turns into x, what that means is if you know the domain and range of the original sine function, then you automatically know the inverse. You just have to switch them. Let's start with the range. What's the highest and the lowest that wave goes? What's the highest and the lowest?
1.
Yeah, the highest is up at 1
And -1.
and -1. That's the range of the original. What do you think that becomes in the inverse? That becomes the domain. So in the original, the range is -1 to 1. In the inverse, that's the domain. Okay, let's go back up again. Let's look at the original. In the original, the domain is -π/2 to +π/2. That's the domain. What do you think that's going to become in the inverse? That's going to turn into the range. So -π/2 to π/2 is the domain of the original, which is going to be the range of the inverse. So that's all that happens with domain and range with an inverse. They switch. In an inverse, the domain becomes the range becomes the domain. The y's turn into x's, the x's turn into y's. And I'll show you in a minute where we would have to use those two facts to do a problem. Okay, now let's think about cosine. Okay, I'm going to draw a picture of cosine. And if you look at cosine, how high and low does it look like that blue wave is going? It's the same as sine. That's the range of cosine, 1 to -1. That's the range of the original. So what is that range going to turn into? It's going to turn into the domain in the inverse. All right, so So there's your domain, same as the domain for inverse sine. And now let me take that and let's try the same trick we did last time. Negative pi over 2 to pi over 2. So if I just look from here to here, it's exactly what I did last time. If I put a horizontal line between those red marks, would it ever hit the graph more than once? Or could it? Yes, it could. So looking between that section, let me draw it a little nicer. Between here and there, it doesn't work this time. But what we can do is let's slide that over a little bit. How about there? If you draw a horizontal line between those red marks now, would it ever hit the blue graph more than once? No, no matter where you put it. Focus between the red lines. It's never hitting the blue part more than once. So now what we've done is we have found an area we can focus on to make the inverse. That's 0 to 180. Okay, so for inverse cosine, if we restrict the domain from 0 to pi, we're good. Well, the domain is going to turn into the range, 0 to pi. Now, tangent looks a little different. Okay, let's look at how high and low tangent goes. What's the highest and the lowest that tangent goes? Infinity and negative infinity. That's the range of the original. So what do you think the domain of the inverse is going to be? So in the original tangent function, the range is negative infinity to infinity. That range is going to turn into the what? Domain. That's going to turn into the domain. So the range in the original turns into the domain in the inverse. Okay? And let's try the same thing. You get the picture? If I draw a horizontal line, would it hit that graph more than once? What do you think, Brandon? Yeah, definitely. Right? If you put a horizontal line, it hits it a bunch of times. That's a problem. It can only hit once. So what we have to do is focus on a section that only hits once. Cool. Let's try what we've done before. Negative 90 to 90. If I focus on what's between the black lines, would a horizontal line ever hit more than once? Anything, AJ? No. No. As long as we ignore every other section and just focus on that one part, then we can have an inverse for tangent. If you don't want to focus on that section, then we can't do it. Okay? We can only have a horizontal line hit once. So that's negative pi over 2 to pi over 2. That's the domain for the original. What's the domain turn into? The range of the inverse. There's your range. Now, notice there's a difference between the way I wrote the range for inverse tangent.
You put parentheses.
I put parentheses. Versus here I put brackets. That's simpler. The reason I put parentheses is because, what do we call those dotted lines? Anyone remember what we call them? What do you think? Say what you think.
Is it the vertical asymptote?
Yeah, it's the vertical asymptotes. Well, if the asymptotes are vertical in the original, and everything changes for the inverse, all the things that are vertical become horizontal, all the horizontals become vertical, what ends up happening in the inverse is instead of those asymptotes being vertical, now they're horizontal. So inverse tangent would kind of look something like this. Instead of going up and down forever, it goes left and right forever. And instead of being trapped between two vertical dotted lines, it's trapped between two horizontal dotted lines. That's kind of what it looks like. Okay, so that's the big idea with inverses. The domain becomes the range becomes the domain. Switch places. All right, so sometimes what we want to do is cancel out a function. If you want to cancel out sine, I said you could use inverse sine, and the two cancel each other out. What I didn't tell you is they don't always cancel out. Okay, it depends. And I'm going to show you when they cancel out. So in this first formula, write it like this. Don't cross out what I'm about to because you need to be able to read it in your notes. But inverse sine right next to regular sine cancels it out because they're right next to each other. And what you're left with is just the x. As long as x is between negative 90 and positive 90. Or if you're doing radians, negative pi over 2 to pi over 2. I'm not going to write every one in radians and degrees, okay, but I will this one. Okay, let's try it. Let's take my calculator in degrees. Somebody give me an angle between negative 90 and positive 90. 3. Okay. So I'm going to take the inverse sine of the sine of 3. Inverse sine of 3. And when I hit enter, what should I get? 3. And I do. I get 3. So inverse sine and regular sine canceled out. Any angle between negative 90 and 90, that works. Okay, give me an angle that's not between negative 90 and 90. Well, 180? Let's pick something even more random.
91.
91, okay. I just want to do something that's totally couldn't be a special case. But if you plug in 91, notice you didn't get back what you started with. There's a pattern to what you got back, but it's not what you started with. Okay. What's the difference between 1a and 1b? If you look at them quick, they kind of look the same, but they're not.
There's a negative 1 over 1a.
And what is that one called? That's the... What's that?
Inverse?
The inverse, yes. In 1a, the inverse is on the outside. In 1b, it's on the inside. So in this case, sine and inverse sine cancel out, but you have to pick a number between negative 1 and 1. Okay, let's try it. Sine of inverse sine, I'll pick a number between negative 1 and 1, 0.65. And I get back exactly what I started with. They cancel each other out. Somebody give me a number that's not between negative 1 and 1. 2. Let's try that. So when I did this before, I got back a number, but it was a different number than what I started with. This time you don't even get back a number. Okay? If you try to use it and it's not between negative 1 and 1, it doesn't even work. All right, so kind of question you might see is something like this. True or false? The inverse sine of the sine of 23 degrees equals 23 degrees. Okay. Step 1 is to match it up with which formula? Inverse is on the outside. That's formula 1a. In degrees, what does my angle have to be between for formula 1a to work? Negative 90 and 90. Is 23 between negative 90 and 90?
Yeah.
Yeah. So this is true. That's the kind of question I would ask. All right, let's look at the ones for cosine. Does anybody remember, what did we say we were between for inverse cosine? It wasn't negative pi over 2 to pi over 2. What was the range? It was 0 to pi. And that's exactly when the second formula works. So all these, what you have to be between things, they're not random. They're coming from the numbers we just went through. And the next one is going to be when the inverse is on the inside. That one's going to have to do with the domain. What is the domain of inverse cosine? Josh? Look back in your notes. What does it say? Did you write it down?
No, I
Then, yeah.
Negative 1 to 1.
Domain, inverse cosine, negative 1 to 1. That negative 1 to 1 comes up right there. So cosine and inverse cosine will cancel each other out as long as you have a number there between negative 1 and 1. Okay. Okay, let's look at the last group for the tangents. Okay. So for 3a, what did we say the domain of inverse tangent was?
Negative infinity to infinity.
Negative infinity to infinity. And the range was negative pi over 2 to pi over 2. Double check that. Range, negative pi over 2 to pi over 2. Domain, negative infinity to infinity. Those two things pop up right here. What's the difference, though, on the condition when 3a is true and the condition when 1a is true?
Can't be equal to.
Right, there's no equal to's. If you look at 3a, it's strictly less thans. Well, remember when I said we wrote this? We had parentheses on the range. And then on sine, wherever it was, we had a bracket. That's why it's different. Okay, let's see, do I have another one? Yeah, let me give you, I'll make up another question like that. Simplify. Let's say cosine of inverse cosine of 0.73. Now you can't write true or false there. There's nothing, it doesn't say equals anything. I'm asking you what it equals. Okay. Out of the 6 formulas, which one does that one look like? 2, which one? Yeah, it's 2b. Regular cosine on the outside, inverse on the inside. Okay. It says that our thing right here should be between negative 1 and 1. And if it is, then that thing I just circled is the answer. is my argument between -1 and 1. So if I simplified that, what would it be? 0.73. Those are the kinds of questions, those are the only two types of questions you would see on any of the 6 formulas on the left. Either a true-false question or simplify. Let's do one more. About inverse tangent of 3 pi over 2. The question is, does that equal 3 pi over 2? True or false? That's false, right? It said that if you look at inverse on the outside, it should have been between -pi over 2 and pi over 2. 3 pi over 2 is triple pi over 2. That's way bigger than pi over 2. It's not between the two that it had to be. Okay, so that's false. Okay, questions on that one? All right. So last thing. When we take an inverse function and transform it, everything works exactly the same as every other transformation we've done all year. Okay, I've written the letters again. Am I gonna write them all? No, I'm not gonna write them all, but I'm just gonna ask what each one does. What does the A do? It would take my graph and shift it which way? Left or to the right? Exactly. A is a horizontal shift. How about B? Horizontal stretch. All the stuff inside the function is always your horizontal. It always does the opposite of what you would expect. Okay, we've said that over and over. So A is your horizontal shift. B is your horizontal stretch. What about if you put a negative in front of B? What does that cause the graph to do? Flip. Causes it to flip. Now that's the horizontal stuff, so all the stuff on the outside is the vertical. C would do what? Vertical stretch. And D, vertical shift. Yep. So if you want to know what's going to affect the domain, domain is X. That's left and right. Things that affect the domain, shifting left and right, stretching left and right. Things that affect the range, that's up and down. Vertical stretch would affect range, so would vertical shift. So we need to know which ones affect the domain and which ones affect the range. So what I'm going to do is I'm going to give you a problem. I'll just scroll down so you can see one. Like that. And I'm going to ask you, what is the new domain? What is the new range? Okay, start with the domain. To find the new domain, first thing is you need to know the original domain. If you don't know the original domain, you're not going to be able to find the new domain. So those formulas I had at the beginning of the class, domain, range for each one, you need those. And I would just put them on a reference sheet because it's kind of confusing to memorize them all, so write them down so you don't have to. And what we're going to do is create a compound inequality. You're going to put the argument in the middle. I'll show you what the argument is. That's the argument. And you're going to put the original domains on the left and on the right. And then solve. Let's set that up before we talk about range. Okay, you can leave a little bit of space to write range, but let's make sure we got that first. Argument in the middle, original domain on the left and on the right. Argument in the middle, What's the original domain for inverse sine? Something you need to think about, just whatever you have in your notes. Negative pi over 2 and pi over 2. There's your domain and range. Negative pi over 2 to pi over 2. There's my range. Now what's the original domain though? You gave me the range, which is good, but I just don't need it for this one.
Is it negative 1 to 1?
Yeah. The domain for inverse sine is negative 1 to 1. Okay. So argument in the middle, original domain on the left and on the right. Whenever you set up a compound inequality, it always points towards the smaller number. And now solve for x, and that's the answer for the domain. Okay. How would you get x by itself there? Do what?
We can make it two separate.
No, we're going to keep it all together. Just keep it as one thing. You could make it 2, but we can keep it all as one thing. Divide everything by 2. Just remember all your rules for inequalities. If you divide by a negative, what do you have to do to the sign? Flip it. Right? Algebra 1 stuff, so I'm expecting we got all that. Okay, if you divide by a negative, you've got to flip it. I didn't divide by a negative here. Okay, so now my new domain is from negative 1/2 to positive 1/2. You could leave it like that, that's fine, or you could do this. That's fine too. So by putting a 2 in front of the x, what you just did is you compressed the domain. You squished it. That's a horizontal compression. Now, what about the range of inverse sine 2x? It's what? First, ask yourself, does that problem do anything to the range? So 10? No? What does that 2 do again? It's a what? The 2 is a
Vertical.
horizontal.
Horizontal. I have no idea.
Want to help her out? It's a horizontal stretch. That's the only transformation in the whole problem. If you stretch something left and right, what does that do to it up and down?
Compress.
If you stretch something left and right, what does that do to the up and down?
Nothing.
Nothing.
Oh.
Stretching left and right does nothing to up and down. So the range in this problem is exactly the same as the original. It doesn't change. There was no change at all in the range. Okay, let's try this one. Okay, we'll do one more with domain, and then I'll scroll back up. So if you didn't copy down how to find the range, we'll do that next. But I want to try another one with domain first before we talk about that. Okay. That's a horizontal stretch or compression. It's one of the two. So I'm going to create a compound inequality. What goes in the middle? The argument. And now we put the original domain on the left and on the right. What's the original domain for inverse sine? Negative 1 to 1. Yep. Inequality symbols always point towards the smaller number, which if you put the smaller number on the left, they always point left. And now, how would you get x by itself there?
Multiply
Yeah, divide by a third or triple everything. Now you're saying x is between -3 and 3. You've taken the domain and you've stretched it by a factor of 3. Now we've done a horizontal stretch. What does that do to the up and down? Nothing. So the domain, I just wrote that, the range stays exactly the same. Okay, let's copy down how we find the new range. Okay, to find the new range, basically, we just try to reason it through. Like, let's say you had a range that was from -1 to 1, and you doubled it. Well, now it's -2 to 2. If you had a range that was -1 to 1, and you said, I'm going to shift that up 1 unit, well, then the range, instead of from -1 to 1, would be from 0 to 2. And you always take them into account in that order. If you do a stretch, do the stretch first, and then shift your range second. A stretch means you're going to multiply each number in the range by a value. A shift means you're going to add a number to the range, each value. Right, so let's try one. What is the what's the +2 doing here? Think about what kind of transformation is +2? It's a vertical shift. Does vertical do anything to the domain? No. So the domain in this problem is exactly the same as the original. There is no change in the domain. What's the domain for inverse sine? It's -1 to 1. But now the range is going to be shifted. Which way is the range shifted? Up 2. So just take what the range was and shift those numbers up 2. There's no nice way to write it, so just write it like this. You're going to shift the lower end up 2. You're going to shift the upper end up 2. That's it. Now, if those were nice numbers, like if the range was something I could do the arithmetic in my head easily, then I would do it. But I can't really do anything with it. Okay, let's try this one. What kind of transformation is the 5? That's a vertical stretch. Vertical affects what? Domain or range? It affects range. So domain is exactly the same. What is my domain? Just make sure you look up the right function for inverse cosine. That's the negative. Let me just go back and make sure we get the right thing. Inverse cosine, domain, -1 to 1. Okay, so -1 to 1. Okay. Now, what's the range? That's what Nina, you started to say. What's the range for inverse cosine?
0 to pi.
It's 0 to pi. We're going to take 0 to pi, and we're stretching that by a factor of 5. So now it's going to be 0 to 5 pi. You multiply each number in the range by the vertical stretch. 0 stays as 0. Pi times 5, 5 pi. Okay, and let's finish up with one with tangent, inverse tangent. Okay, what's the 2? Start with that. What's that doing? Stretching which way? Horizontal. Now, what was the domain of inverse tangent?
Negative infinity.
It was already negative infinity to infinity, so if you double that, still negative infinity to infinity. So whenever you have a question with inverse tangent, the domain never changes. Always negative infinity to infinity. What was the range for inverse tangent?
Negative pi over 2 pi over 2.
And we're tripling. So instead of negative pi over 2 to pi over 2, triple it. It's negative 3 pi over 2 to positive 3 pi over 2. And did the range here have brackets or parentheses? Parentheses. Somebody tell me, let's just look at this. What are the transformations that are happening there? There's 3. What's the first one? Yep, which way? Shift 8 left. Vertical stretch by how much? Factor of 3. And a vertical shift which way? So you could just say shift down. If you tell me down, I know down is vertical. Shift down 5. Any questions on that? Guys, there's still one more thing I got to show you before the test. What's on the calculator? Sorry. You don't have to use your calculator. It's up to you. You can just watch. But I'm going to show you, so at least I can say I showed you. So it's how to type an inverse trig function in on the calculator. Actually, you tell me. Does anyone want me to show you how to do it?
Yeah.
Okay. So on a graphing calculator, you have to press second to get at any of the inverse trig functions. So I'll do the first one. Second, and then sine. Okay. Type in the argument, and then if they want degrees or radians, you need to change the mode. This question doesn't say, so you can do it either way. So the answer to the first one is 30 degrees. That's it. That's how you type it in. Does anybody know what's going to happen with C when I type that in? Think about what's the highest and the lowest that the sine wave ever goes? 1? Negative 1 to 1. You're picking a number that's above the sine wave. Well, that's a problem. You can't do that. So C is undefined. B would have a solution, and so would D. Okay, but the way you type it in is second, and then your trig function. And that's it. Okay. Any questions on that? All right, so homework, 1 through 9, it's odd. For 13 through 20, you need a calculator for every one of those. Those are all, you just type it in on the calculator and hit enter. And 22 and 24, you can use a calculator as well. It says not to, but don't worry about it. And then 27 to 32, it's all calculator. So you need a calculator for almost every problem.
Is it odd for all of them?
1 through 9.